No, it's nothing bad, just a conversation. So then I didn't want a whole conversation in the middle of my video. All right. So transformations is what we're going to be talking about in Unit 9. Everybody go ahead and close or halfway close your Chromebook so I know you're not on it right now. We'll be on it quick enough and you'll be able to work on your ALEKS. The one we're going to focus on today is translations, probably the simplest, one of the 4 transformations we're going to work with. The transformation is a change in position, size, or shape of a geometric figure. And there are 4 types of transformations that we will cover. The first one there is a rotation. What does it mean when you rotate something?
Turn it.
You turn it. So we're going to call the rotation, or refer to that rotation also as a turn, right? You can turn things clockwise or counterclockwise. So when we get to the lesson devoted to rotation, we'll talk about that more. But it's a turn. It can turn this way to get the new image, or it could turn this way to get the new image. That would be a clockwise, goes the same way as the clock goes, or a counterclockwise, so it goes the opposite way. The translation is the one we're going to work on today. So, do you guys remember what a translation is? What's the word we use for a translation?
Translate.
No?
What's the start? What's the letter? Relocate.
Okay, well, let's just talk about these 2 and see. So this is the original. This is the new.
Yep.
Did we turn it?
Nope.
No. We just moved it. We moved it up and to the right, right? Or to the right and up.
Rise or run.
Not right at the run. It's just a slide. If we're just sliding it up, if I slide this from one spot on here to another, if I move it, it's just a slide. Right? So we can slide it left or right, or we can slide it up or down. We're not going to turn it or anything. It's just a slide. The reflection, like you're looking at yourself in the mirror. Your reflection in the mirror, it's exactly the same thing, but everything is backwards. And for our purposes, we'll be reflecting things about the origin, or we'll be reflecting over a line. And this one is reflected, well, I guess it doesn't, you could say it either way. But, so we're just going to call that a flip. It's just flipped over that line, right? What's happening with this one? So if we say this black line is the original and the gray is the new, how do we go from here to here? What do we have to do? You got bigger, right? So the dilation, can dilations also get smaller?
Yep.
Yeah. I didn't used to know that. I used to think when they dilate your pupils, that means it only gets bigger, right? But you can dilate your pupils larger or smaller, and we can dilate a figure to make it larger or smaller. So we're going to enlarge or reduce. When we enlarge or reduce as a transformation, it would be a proportional enlargement or reduction. So the shape is going to stay the same. The angles would stay the same, but the size would be different. So of these 4, 3 are a rigid motion, 1 is a non-rigid motion. Scratch out that E, it's not non-rigid, it's non-rigid there. It's not non-rigid, it's non. Scratch that E out. Non-rigid motion is a movement that changes size or shape. So which one is the non-rigid? Shrag? Dilation, that's exactly right. All the others keep their size and shape. They're moved, they're turned, they're flipped, but their shape and size does not change. Part of the lesson today is just showing you how to kind of talking you through the kind of problems that ALEKS uses and the way you have to click on things and stuff like that. What are they asking you to do with this translation topic? Okay, So one of the things we need to know is how do you name the old image and the new image, right? So the transformation is shown with the pre-image, the original, and the image, new. A prime notation, and that's just an apostrophe, is used to identify the points of the image or the new. So look in here, these have the apostrophe, so that's the image. This triangle has the apostrophes on its vertices. So this is triangle A prime, B prime, C prime. That's the new one. Triangle ABC, that is the original, or the pre-image. Sometimes they'll say the figure and the image, something like that. So look in here. Oh, forgot to cover that up. A translation is a transformation that moves all points of the figure the same distance in the same direction. So if A moves to the right 9, then B moves to the right 9 to get to B prime. Then C moves to the right to get to C prime. Okay, so if this arrow is pointing to the right, they all, when we translate a figure, one of the easiest ways to do it, if we have to actually draw the image with the tools, is just move each point and then use the connector, the line connecting tool, the line tool on Alex to complete your figure. Translations are slide, and this is a non-rigid motion. So we're just sliding it left or right or up or down. And we can slide it left or right and up or down, right? It's still a translation. All right. I labeled this point B because I can't just move it on here like you can on Alex. And also, you're going to have to name the original point and the new point, the pre-image and the image, and I didn't know how to do that without labeling this point. So let's go ahead and label that point B. Since the figure below is a point marked with a large dot, so a point B marked with a large dot. First, translate the figure 7 units to the right and 5 units down. Then give the coordinates of the marked point in the original figure and the final figure. So, I'm not sure if it wants you to do the whole figure here. I guess the whole figure here. So let's do the whole figure. So how do we get, if we go 7 units to the right, we're going to start here and go 7. 1, 2, 3, 4, 5, 6, 7. We're going to wind up there, but then it says down 5. So from there, we're going to go down 1, 2, 3. Oh, my thing is off. That's 5. Yeah, I'm down. So over 7 brings us to here, and down 5 brings us to here. Thought it'd be cute with those arrows, but I was not cute. So we're going to name the image B prime. So we're going to give our ordered pair for B and our ordered pair for B prime. We're not going to translate that whole image right now. Actually, no, we are. I lied. So we're going to do B prime, and now let's do this point 7. It's going to be over the same amount, and down 5. It's going to be right here. So to translate it, you just translate every point the same amount right and the same amount down. So over 7, down 5, over 7, and down 5. then we use the line tool on Alex. I think you are going to have to translate the whole thing. And some of these you're going to translate the whole thing and you have to give all the points, but 1, 2, 3, 4, 1, 2, 3, yeah, you did it right. So what is the coordinates of B? Remember to find the coordinates of a point, you start the origin and you count left or right and you count up or down. So you go left to get to B, so go left even with -8, that's the x-coordinate. And then how far do we have to go up? Well, we go up 1, positive 1. Now our B prime, we start the origin, left 1, so that's -1, and then down 4, -4. So here they told us to go right 7 and down 5. If you'll notice, if we take -8 and we add 7 to it, we get -1. If we take 1 and we subtract 5 from it, we get -4. So we can just translate the figures, and then look at the coordinates. Or you could use a shortcut sometimes, then subtract the old minus the new, and that'll show you the move. Any questions so far? Okay. So for this one, it asks you to shrug. I don't know. I know because you're going to tell me to move, and I'm going to stand right here today. You can just try to stay awake today. Sure. Can you write while you're standing back there? As long as you're not talking to anybody. All right. Translate the figure up 7 units and decide if each statement about translated figures is true or false. So you're going to be able to just grab that with a hand and drag it up. I can't do that. But I can quickly translate it up 7 units. So if I translate that up, you're going to be able to drag and drop it on Alex, on me, but I can't. So once we drag and drop it, drag it up 7, then we need to be able to answer these questions. Remembering that we said that the translation, so this is a translation, right? And we said the translation is rigid or a non-rigid motion? Rigid or non-rigid? Non-rigid. So that means the shape is not going to change, right? Side lengths won't change, the angles won't change, the size or shape won't change. So if 2 sides are parallel in the original figure, then the 2 sides are parallel in the final figure. Or we just said they're not going to change, and we can see from here, these 2 sides are parallel, they're still parallel, right? So that's true. The final angle measures are the same as the original angle measures. We didn't change the shape or the size, so that one's true. The final side lengths are longer than the original lengths. Well, it's pretty easy to count these. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. But really what we need to remember is that it's a non-rigid motion. Those side lengths can't change. Otherwise the size would change. The original figure and the final figure are congruent. Do you think that's true or false?
True.
It's true, right? If you don't change the size or shape, we just translate it up or down, left or right. Uh-oh. This is supposed to be a false. All right, questions on that one? All right. So you're going to be able to drag and drop these. It says in each part, translate the solid figure exactly onto the dashed figure. If this is not possible, click on not possible. Do you think it's possible with this one? Yeah, so we can click on it and grab it, and you can see it doesn't look exactly like this when you do it on Alex, but pretty much it's lining up exactly the same. So we're going to say that is possible. On Alex, you don't have to say that because you're going to drag it. Here, I can click on it and drag it left and then up. But is it going to be, can I translate it exactly to the dotted line? Cannot, so that one's not possible. Because I would have to change the size, right? I'd have to enlarge it. I can't, that's not a translation. You awake, Lynn? All right. We are going to translate this 1 unit to the right and 4 units down. If you're feeling froggy when you do it, want to do it, you can. But first, let's make a note. 1 unit to the right means right 1. 4 units down means down 4. That's pretty self-explanatory, right? This is a +1 change in x's. This is a -4 change in y. Something we should start tuning into.
That triangle makes it look like that?
It's actually not a triangle, but I'm with you, Sherrod. It looks like a triangle at first. I read the problem and it said quadrilateral, and like that is wonky, but this is a vertices and this is a vertices, so you can see that segment, this segment. So it's actually a 4-sided polygon, quadrilateral. Straight side closed. So we're going to go 1 to the right and 4 down for all of these. So you guys can do that with or without me. I'm going to do it. Y'all can do it too. We can double check that you got it right. So to translate the figure, just pick the vertices and translate them all. Right 1 down 4. Let's do a different color. Right 1 down 1, 2, 3, 4. Right 1 down 1, 2, 3, 4. Right 1 down 1, 2, 3, 4. And finally, right 1 and down 1, 2, 3, 4. So right 1 down 4. Right 1. Oh, did I do that? Right 1 down 4. Right 1 down 4. Right 1 down 4. And right 1 down 4. So now we're going to connect those with the line tool. You will be doing this, the line tool on Alex.
So they can't cross those.
Yeah, they can cross. Yeah, they could be, they don't have to be completely moved off one another. So this is the pre-image, and this is the image. You awake? Lena, when you put your calculator away, will you put the one behind you away as well? Okay, are y'all caught up with me? Anybody have questions about that? All right. So, we've been talking about what it means if you move something right or left, or if you move something up and down. A little refresher, remember on the coordinate plane, anything to the right is plus, so we go right 4, we're adding 4 to our x-coordinate. If we go left 4, we're subtracting 4 from our x-coordinate. If we go up 3, we're adding 3 to our y-coordinate. If we go down 3, we're subtracting 3 from our y-coordinate. In the coordinate plane, the point x, -4, 3 is translated to the point x prime, -3, -2. Under the same translation, the points y, 0, 5, and z, -2, 0 are translated to y prime and z prime, respectively. What are the coordinates of y prime and z prime? It's a very confusing question. All we have to do here is figure out how do we go from x to x prime, right? What do we do to the x's? while x is negative 4, 3, x prime is negative 3, negative 2. We need to look at what happened in between the x coordinates here. How do we go from this y coordinate to this y coordinate? So we're looking at x and y coordinates. We need to figure out that rule. What do we add or subtract to x to get x prime? The x coordinate of x prime. What do we add or subtract to the y coordinate to get the y coordinate of x prime? You can graph it and count it, or you can use old minus new. Right, so negative 4 plus something will equal negative 3, or negative 4 minus something will equal negative 3. If you're not sure, then just use the math. Negative 3 minus negative 4 equals 1. So if we add positive 1, if we add positive 1 to negative 4, don't we get negative 3? Sorry? You can also visualize it on the coordinate plane. You could plot this point on the coordinate plane and just count, Dominic. Just count how far did you move up or down, right? We could plot the point and count, or we can use just subtraction. So here, 3 minus negative 2, that's 5. So, add 5. Is that right? Yeah. No. Let's see. 3 minus negative 2. Oh, yeah, it is negative 5. What did I do?
You thought 3 was.
Oh, I did the new minus. I did the.
Oh, you used the last one.
Yeah, we need to do the new minus old, not old minus new, not the new minus old, not old minus new. Sorry about that. Okay, so it's new minus old. That's what I did here. New minus old, and this would be negative 2 minus 3, which is negative 5. You don't have to do this. If you can see what to add or subtract to it, you can just do that. So now we know for these other coordinates, we're going to add 1 to the x coordinates, and we're going to subtract 5 from the y coordinates. So for y prime, let's see that there. Y is 0, 5. So let's look at y, 0, 5. So y prime is going to be 0 plus 1, and 5 minus 5. So y prime is 1, 0. D is negative 2, 0. So we're going to add 1 to the x coordinate. Remember, this is x coordinate, y coordinate, x coordinate, y coordinate. So now we know d prime x coordinate, negative 2 plus 1 is negative 1. And 0 minus 5 is negative 5. Okay, so we figure out the rule, figure out what you have to do the x coordinate and the y coordinate of the one point to the other. Graphing it, sketching a little graph if the numbers are small like this is an easy way to count. Right? I think you could literally count from one point to the next and then look at what the order pairs are from there. With me? All right, so this figure, triangle ABC, triangle A prime, B prime, C prime. The apostrophe is there. The prime tells us that that is the new image. This is the image, this is the pre-image. This is the original, this is the new. So this example 6A asks us to just find the coordinates of the prime triangle. The triangle A prime, B prime, C prime. Can you guys write the coordinates of A prime, B prime, C prime there? That's what you're doing here. So the coordinates of A prime start at the origin, if you go left, this means it's negative. So we get even with A, that's negative 4, and then up 4. G prime, start at the origin, we don't go left or right, so 0, left or right, up 2, so positive 2. C prime starts at origin, we got to go left, that's negative, left 5, up 1, positive 1. You should all be able to do that. It's going to be a struggle if you cannot determine the coordinates of points. So far, so good? All right, they're giving you these two sets of points. Now you guys find the rule. Like we defined the rule in the last one. What are we doing to the x-coordinate, and what are we doing to the y-coordinate? So let's look here. How do we go from 2 to negative 4? You can plot it. Well, we can actually count it over here because we haven't plotted, right? So what do we have to do? So you go from here to get even with A prime with 2, 3, 4, 5, 6. Left 6, does that make sense? So left 6. And remember, you could do negative 4 minus 2, which is negative 6, right? So you can use that subtraction, or you can just count on these. So let's see if that works for all the x's. So I know 2 minus 6 is negative 4. I know 6 minus 6 is 0. I know 1 minus 6 is negative 5. So that appears to be the rule for our x's. Does that make sense to y'all? So what's the rule for our y's? What does it do to go from negative 5 to positive 4? Now these are on the y-axis, so we're going up and down, right? It would be 9. So you can use the subtraction, or you could just count. Well, up 7, 8, 9, so up 9. So we see that it was up 9, and we can double check that with 4 minus negative 5. So the new minus the old, which is what I messed up a second ago, right? So let's see if that rule works for all of them. Well, negative 5 plus 9 is positive 4. Negative 7 plus 9 is positive 2. Negative 8 plus 9 is 1. So now the next thing is, which one of these notations says that we're going to take our x's and subtract 6, and our y's and add 9? So this means we're multiplying by 9. Are we multiplying our x-coordinates by 9? No. So we can skip that one. This says we're multiplying our x's by 6. We're not multiplying anything. We're adding and subtracting to x and y, right? More multiplying. Here this says x plus 6. Did we add 6 to our x-coordinates? No. What did we do? Subtract 6. Okay, so that one's not going to work. That one's not going to work. So you said that one and that one's not going to work. How about this one? X minus 6, y plus 9. We subtract 6 to the x-coordinates, yes. We add 9 to the y-coordinates, yes. So this is the answer. More multiplying there, those can't be right. Now here, they're just using the wrong moves on the x's and the y's, right? So that's how you do them. Anybody need to go back to any of the other pages? Okay. We're not going to scan to this right now. We're going straight to our work on Alex. You can scan it, submit it, start home later, or right before the bell rings if you like. Possible and not possible.